So here we are, we're at the last of the 4 videos for data analysis, and it's a chance to put together all of the work that we've seen so far. It's a story about some items that are orbiting around some asteroid, floating in the middle of the universe somewhere, and ultimately your goal is going to be to try to determine the mass of this asteroid based on the orbit times for a few different things going around this asteroid. You got a grand piano, an astronaut, and a Winnebago. Now in the data table, you can see for those items how far they are out, what the radius of their circular orbit is, and how much time it takes for them to go around. Plus there are some courtesy columns that you're going to need, and here's why. The physics behind this story, sometimes called Kepler's third law, looks like this. T squared r cubed is t squared on top of r cubed is equal to 4 pi squared all on top of big G big M. And you are trying to figure out the value for big M. Big G is a constant. It's actually mentioned right down here. Right? You might need that a little bit later in your calculations. But you are definitely looking for the value for big M. So things that are changing. There are so many different data points in this story, right? There's a data point for a piano, an astronaut, and a Winnebago. Lots of different values for T and lots of different values for r cubed. And as I circle those, that does not look like Math 10. So this needs to be rearranged a little bit. My advice, instead of graphing T and R, because that just doesn't work at all, maybe consider graphing T squared and r cubed. Okay, you got to rearrange that equation just a little bit more. Maybe make this one your up and down axis so you can leave T squared by itself on the left. It's got to be by itself though. So maybe move that r cubed to a different location. And in this story, there are a lot of T's and a lot of R's, but there is only one value for 4 and for pi and for big G and for big M. So your goal is going to be to create a graph, find the slope off of the graph, and then say, hey, that slope is equal to this stuff. That's what it represents. And then ultimately calculate the value for big M. So it looks like you are going to need, in order to be ready to graph, you are going to need r cubed values and t squared values. So this table, as a courtesy to you, has some room for where you can take these numbers like the 64, the 162, the 242 and cube them. And you can also square your values for t in order to be ready to graph, because you want to graph those t squareds and r cubes on your graph. Okay, and there's some room on the back page, okay, on this last page to do your graph. And you can decide which axis you want to be up and down, which one you want to be over. If it was me, I'd make my t squared my up and down axis. My r cubed can be my over axis. But you do have to rearrange the equation to prepare it for graphing, circling the axes. Maybe put your answer here. And then you're good to go. You can find the slope off of your graph, off the best fitting line, and then use that experimentally determined slope value to figure out the value for big M, the mass of the asteroid. Good luck. If you run into any troubles, feel free to ask me in class, and I can help you out. When it might even be something as simple as, hey, having some trouble scaling my axes with that 1, 2, and 5 thing. But that's it. That's the last assignment. When you're ready, you can hand that in.